it's more pleasant to read this way than it is in the usual web format. We've also played some games with this issue of The Guardian by, for example, replacing an ad with a very high resolution ad. It's higher resolution than you would be able to see in a print format. And we've also made it a multi-resolution ad. So this is just, you can just sort of play interesting games like this. Other cars, perhaps this fictional car manufacturer might have manufactured, and even the technical specifications of the car and so on. So you can do things with this that simulate physical media, but also that go beyond simulating physical media. This is, of course, the most obvious sort of thing you can do with a multi-resolution representation of visual information like this. It's a map of the world. I'm cheating here. It's not a real mapping application. It's just a layout of a series of tiles in 3 dimensions that sort of see what we're doing there. But the idea here is that there's a high-resolution NASA image of the U.S. Space Agency, high-resolution image of the Earth, and layered on top of that, within the U.S., are a series of tiles of street maps. Now, since we have the time, it's just interesting to have a quick look at what's going on here, because I think it's quite interesting. This representation of street maps and this way of doing street maps is very different from the sort of thing that you see on the web in a number of ways. One way is, of course, that when you're looking at street maps on the web, you have discrete levels of zoom, typically, meaning that there are only certain zoom scales that are allowed. Maybe flash, in some of the fancier mapping applications, you can use flash or Silverlight or something to provide at least a continuous transition between those discrete levels of zoom. But it's all discrete, and here it's continuous. But the other thing is that if you look at conventional mapping software on the web, you'll find that the streets of different types are only present at certain zoom scales, and they disappear at other zoom scales. So, for example, if you look very closely at a map online, then you'll see all of the streets. But if you zoom out to here, you'll stop seeing the small streets, and you'll see only the larger streets. And then out here, you'll stop seeing even the larger streets and see only the highways, and so on. Now, one of the things you might notice in this demo is that every street is visible at every scale. Now, I'm sorry that the overhead projector is saturating this image a little bit, which is preventing you from getting the full effect. But all of these little country roads are visible, at least on my screen, even out at this resolution. And that's a very nice thing because that's a very nice thing because it means that you don't have any discontinuities in the available information across scales. There are some interesting tricks to doing that, and they're tricks that I think are more broadly applicable than just street maps. So I'll spend just a moment describing what's happening here. Now, in general, if you think about mapping in streets, there are 2 obvious approaches to rendering a line drawing of streets on a map. One of them is to use the physical scale of the roads, meaning that the widths of these streets are exactly their physical width in meters. And if I were to superimpose an aerial photograph, I would see that overlap precisely with this image. If you do that, then when we zoom out to this level, you would see nothing but white on the map. Because at this point, even the largest streets would be about a 30th of a pixel wide. Okay, so physical scaling only works when you're zoomed in. Now, if on the other hand you use the kind of approach that normal mapping software uses, and you say, okay, we're going to forget about meters, and instead we're going to draw lines in pixels, and we'll say a small street is 1 pixel wide, and an arterial street is 2 pixels wide, and a highway is 3 pixels wide, and so on, then at this scale it would look black instead of looking white. And we would see just a complete mess of streets, and you wouldn't be able to make anything out. So what's going on here instead, for those of you who are mathematically minded in the audience, is that it's using a property of streets, which is that they have a fractal dimension. Okay, they're fractals, just like the Mandelbrot set that I showed earlier. And what fractals, a property of fractals is that they have power law scaling. So power law scaling in their width, which is designed to invert their natural power law scaling relationship to each other. I don't know if that makes any sense to anybody in the room, but you can think about it sort of like this. As I zoom out, the streets are simultaneously getting thicker, but they're getting thicker more slowly than my scale is making them get thinner. In other words, they're getting thinner, but they're getting thinner more slowly than they ought to. And so it gives you the illusion that you're zooming in and out of a physical image. I mean, if I'd simply zoomed in and out of this image, I'm sure all of you would think that this really is just a picture, just a pixelated image, just like the other ones. But it's not. Something very different is going on as I zoom, and in particular, the different kinds of streets are behaving differently. The large highways are shrinking more slowly than the small roads, and so on. So there are all sorts of tricks like this. I only show you this to give you a sense of some of the sorts of games that you can play when scale is continuous and when you're allowed to play with multiple scales of data however you want. All right, so all of these demos that I've been showing you of Seadragon have actually all been based on this same collection of a couple of thousand objects, and they're all taking advantage of hardware acceleration on the PC, which is something that has been given to us by the gaming industry. The story of how the internet and how computers have evolved over the past few decades is very, very interesting, and often innovations are driven by very strange market forces. In this particular case, the market force that has driven the development of graphics hardware on commodity computers has been the gaming industry. 3D games keep on pushing graphics and making them more realistic and more high fidelity and so on. But there aren't very many applications out there now that make use of that graphics hardware in interesting ways other than games. And one of the things that we're trying to do is to change that.